Hello, today we're doing lesson 4.1. We're going to graph quadratic functions in standard form. Tomorrow we're going to graph quadratic functions in vertex form. So same idea is going to happen with the graph, it's just the way they're represented in the equations is going to be a little bit different. Okay, quadratic function in standard form is y equals ax squared plus bx plus c. You need to know this. This is called standard form, where the exponents are descending and our constant is last, where a does not equal 0. The graph of a quadratic function is what we call a parabola. A parabola is a U-shaped graph. The parent function for the family of all quadratic functions is f of x equals x squared. This is what it looks like. Again, we have the vertex at 0, 0, just as we did with absolute value functions, but this time our graph is a U, not a V. We also have an axis of symmetry like we did yesterday, which is a vertical line through the vertex. And we have steps to graphing quadratic functions. First, we're going to identify the coefficients, and then we're going to find the vertex. We find the vertex by using negative b over 2a. That's going to give you the x coordinate of it. Whatever we get, we're going to plug that into our original equation to get the y coordinate of it. We're going to draw our axis of symmetry, and we are going to identify and plot the y-intercept, which is 0c. And we're going to go ahead and reflect it and then draw our U. So there's a lot of steps here. I'm going to talk about it as we go ahead and do the problem, but there's some other stuff I want to talk about. The vertex's coordinate is the minimum or maximum value of a parabola. Okay, it's a minimum if A is positive. That means our parabola is opening up. It's a maximum if A is negative. That means our parabola is opening down. The domain, this is where we're going to come into interval notation again. The domain is all of our x values. Domain is always x. As we notice, this parabola is getting wider and wider and wider and wider. So our x's are actually going to keep going to negative and positive infinity. Our domains will always be negative to positive infinity, which is all reals. Our range is our y values. So in this case, where a parabola opens up, this is going to be our bottom number. The y of our vertex is going to be our first number, and it's going to go to positive infinity. Now, if we have a maximum, if the parabola opens down, it's going to start at negative infinity, and it's going to end at the y of our vertex. And like I said, all of this will make much more sense when we go ahead and do the example. But I want you to use this front page as a reference when you're trying the U-tries and the problems on your own. Okay, so let's go ahead and get started with this problem. Okay, first thing we're going to do is we're going to go ahead and find the vertex. Actually, the first thing we're going to do is we're going to identify our A, B, and C. So our a is a number in front of the x squared, our a is -1, our b is 6, and our c is 8. Now I'm going to go ahead for the vertex, and I'm going to do negative b over 2a. This is going to give us our x value. So negative b would give me -6 over 2 times -1. So -6 over -2 is +3. That's going to give me two things. That's going to give me the x value of the vertex, and it's going to give me my axis of symmetry. Your axis of symmetry, remember, is a vertical line over the vertex. Now we're going to go ahead and plug in 3 into the original and find our y value. Now be careful. You're not squaring -3. You're squaring just 3 and taking the opposite of that. That gives me -9. Then we're going to do 6 times 3, which is 18. And then -8. When you do that, you get 1. So our vertex is going to be 3, 1. So let's go ahead and plot 3, 1. Let's draw our axis of symmetry. Try to draw it nice and neat. Okay, now our y-intercept is always going to be 0, c. Our c in this problem is -8. Now I'm going to plot this. 0, -8. Okay, then you're going to reflect this. 1, 2, 3, 1, 2, 3. Now we're going to go ahead and make our upside down parabola. Our parabola is opening down. Now our domain, it's getting wider and wider and wider. It's going to be all reals, which is -infinity to positive infinity. Now our range are our y values. So it's coming from negative infinities. It's going down forever. Negative infinity, and it's going to keep going up until I hit my, Uh-oh. Shoot. There we go. Until I hit my y value of my vertex, which is going to be +1, and it can equal it. I'm sorry I'm off here on my lines. Okay, let's take a look at the next problem so you can kind of get the hang of what's going on here. Okay, same steps. Step 1, identify our A, B, and C. A is 2, B is -8, and C is 6. I'm going to do -b over 2a, so I'm going to plug in +8 because we have the opposite of -8 over 2 times 2. So this is going to give me 8 divided by 4, which is 2. I'm going to plug 2 into this equation, so we have 2 times 2 squared. Please remember to do order of operations. When I do that, I'm going to get -2. Our axis of symmetry is going to be the same as the x value. Our y-intercept is going to be 0, 6. Our domain is going to be all reals. Okay, now let's graph this so we can talk about the range. So my vertex is 2, -2. My axis of symmetry is right on top of that vertical line going through the vertex. My y-intercept is 0, 6. Now we're going to 2 to the right, 2 to the right. We're going to make our parabola. We're going to make sure it's U-shaped, not V-shaped. Now this time our range is going to positive infinity. So it's starting at our lowest point, which is the vertex. So it's starting at -2 and it's going up forever. Now I expect when you try this next problem, you follow all of my steps I did in these 2 problems. I want you to pause the video and go ahead and try that. Okay, welcome back. We're going to find the minimum or maximum value. What am I asking you to do when I say find the minimum or maximum value? I'm asking you to find the vertex. So we want to make sure these are written in standard form. We want to identify our A, our B, and our C. And we're going to go ahead and just practice finding the vertex. So we're going to do -b over 2a. That's going to give me -8 over 2 times 2. That's going to give me -2. I'm going to plug -2 in. I want you to try this. We're going to put -2 into here and here. Watch your signs and watch your order of operations. When you do that, you get -2 and +24. So how do I want to see the answer? Usually I ask you if we have a minimum or maximum value. Because it leads with a positive, my parabola is opening up, which means I have a minimum. So I would like you to write minimum. And what is the minimum value? It's the lowest point. My graph is very off because our lowest point is actually +24. It's way up there. So minimum and 24. Let's go ahead and try this problem. Be very careful because of the fractions. So this is our A, this is our B, this is our C. We're going to do -b over 2a. So -b is going to end up being +4 over 2 times -3/4. Okay, you can punch this in your calculator, but if you do so, I caution you to be very, very, very careful and put your parentheses around the entire denominator. Or we can do it like this. 4 divided by, what's 2 times -3/4 is -6/4. So you can put this in your calculator, putting parentheses around the entire denominator. Or we know when we divide fractions, we change the sign to multiplication and flip the fraction. But either way, you're going to end up with our x value to be -8/3. Then be very, very careful when you plug -8/3 into the x's. When you do that, you will get 13/3. So how do I write my answer? This time it leads with a negative, so I know my parabola opens down. So I know I have a maximum value because this is going to be our highest point. What's our maximum value? The y value. How high up does it go? To 13/3. It's okay if you have decimal too. If you had decimals, you would have the vertex to be -2.7, 4.3. Okay? I do want you to pause the video and try this last you try on your own. You're basically calculating vertex. You're doing the -b over 2a, and whatever you get here, you're plugging it in for your x's. Do not leave this problem blank. And then if you have any questions, comments, or concerns, go ahead, write it at the bottom of the paper, and I'll see you tomorrow in class.